besides just doing regular multiplying numbers together, like we did up here, the distributive property is really, really important for algebra because we don't have numbers all the time. We have variables more often. Well, after the first few weeks, we have tons of variables and not very many just straight multiplying answers. When we have variables, it works the same way. We just do what's on the outside times the first number. So that's 2 times a plus 2 times 7. I don't know what the letter A is, so we have to keep it like this. That's as simple as we can go. We don't know the answer for A, so I don't know what 2 times A is. That means we just leave it like that. And then 2 times 7 makes 14, and that's as far as we can go. 7 times H. 7 times H is 7H. 7 times negative 10, or minus 7 times 10, 7H minus 70 is the answer. 3 times the first number plus 3 times the second number. I stopped putting the dot because these are just a number and a letter, and if there's a number right next to a letter, side by side, means multiply. That's how we know that this 3 on the outside is going to multiply each of these inside. Here we have 3 things: 2 times x minus 2 times y plus 2 times 1, 2 times 1. The reason why you should draw the lines above for distribution is because it makes sure that you don't forget any of the numbers that you needed to multiply. I forget to write the lines because I've been multiplying for so long that I don't need the lines. But you should definitely draw the lines to make sure that you are multiplying the first number, the second number, and the last number together. And this is going to make 2x minus 2y plus 2. At the bottom, we have 2x plus 8x, and it just says to simplify. Simplify means combine like terms. Combine means add or subtract, do whatever you need to get them together. And now you're going to need the definition of a like term. Like terms are either a number by itself, a variable, which is a letter, or a number times a variable. That match. What that means is, for this one, we have 2x and we have 8x. We have the same letter. We have the same letter x, and then we just have different numbers in front. So I have 2x's plus 8x's, and together those are going to make 10x's. And 15. I have 2x squared plus 6x squared. That means the variables are matching up. The variables are the same exact letters. It's an x squared and an x squared. Because they're the same variable, I can add them together. So if 2 terms have the same variable, then you can add them. Or combine them. If two terms have the same variable, then you're allowed to combine them. In number 14, we have a G and a G. Those are the same letter, so we can do 17 G's plus, how many G's is this? It's just one G. If there is no letter in front, if there's no number in front, then that just means that there is 1 times that letter. So 17G plus 1G makes 18 G's. We should do 2N plus 2 times 2N, which makes 2N plus, if you have two numbers that are multiplying, you just multiply the numbers and keep the letter the same. 2N plus 4N makes 6N's. And now we'll finally get to one that's different. 3Q squared plus Q minus Q squared. We need them to have the same variable. Same variable. Here's a Q, here's a Q, here's a Q. But we're going to add something here. The power of the variable also must match. So I have Q squared, I have Q squared, and this one is just a regular Q. I can combine these two Q squareds, but I cannot do this Q. This Q is different. So I can do 3Q squared minus Q squared, and then I'm going to have to add the Q at the end. So if I can combine the first two ones, I have 3Q squared minus Q squared. That's going to leave me with 2Q squared, and then that plus Q, it's going to have to stay by itself because the power doesn't match. We have something to the second power and then something to the first power, and so they cannot be combined together. Like in number 17. In number 17, I have y squared, and here I just have a y. Since they have a different power, I can't combine these together. It's as simple as they can get. This is already simplified. And the last ones, it wants you to write an algebraic expression. If we're writing the algebraic expression, that means we're going to turn words into math, which means the numbers and the letters. So the product. Product means we're going to multiply something. It says we're going to have the product of 9, so we put 9, and t squared. So 9 and t squared are going to be multiplying. So I put the letter T and squared it. The next part of the sentence says increased. So that means I'm going to add together. The sum, so what I'm going to be adding together is, this sum means these two things are adding together. So I'm going to be adding to this the sum of t squared and 2. So I'm adding t squared plus 2 onto 9 times t squared. Three times the sum. So 3 times the sum. Whenever they use sum, there's a good chance you're going to need a parentheses. The sum of r and, because I put a plus sign because it said sum, d squared minus 2 times, so 2 times means 2 times the sum of r and d squared. R, and then it said sum, so I'm putting a plus sign, d squared. Oh, it says that after we write the algebraic expression, then we need to simplify it. So that means I do need to add these things together. So 9 times t squared plus t squared plus 2, 9t squared plus this t squared makes 10t squared plus 2. And then here I have 3 that's going to multiply. 3 times r plus 3 times d squared minus 2 times r. And then this is plus, oh wait. Because this is a negative 2, it's not just a 2, but there's a minus sign in front. That means it's going to turn both of these answers are going to end up negative. So this is minus 2d squared. So this is 3r plus 3d squared minus 2r minus 2d squared. And for this one, we should rewrite it. We're going to use the commutative property. We're going to change the order. We're going to put 3r minus 2r. We're going to put the r's together first, and I'm going to put the d's second. 3d squared minus 2d squared. My r's, 3r's minus 2r's. 3r's minus 2r's are going to leave me with 1r, just the single r. And then 3d squareds minus 2d squareds is going to leave me with just a single d squared. And since I use different colors, I'm going to put it back as just a single color. R plus d squared is my answer. It seems like this is a lot, but it's really not. We just changed the words into math, and then we simplified using the distributive property.